Hello, everybody. Thank you for being here today with us. I'm Jesus Cuadrado. I work at product team at Xygeni. I'm today here to talk about something that I think that we are familiar with every day today. Okay. Probably you are represented here where we have a new way of developing software and we are facing new challenges. So what we find usually is that our development teams are accessing new capabilities and delivering new versions of the software with a lot of changes every day because they are accelerating and they are delivering a lot of new functionality through automation, through support of assistants that they are generating code, a lot of different things. The problem is that the security teams are not aligned with this increase in the rhythm and they cannot keep the pace. So this is because they are still working with a traditional set of tools and a traditional approach. So at the end, they usually only can review a couple of changes a day. Probably they are missing some reviews and some important things. As a result, we can find that in some moment, we can find that one malicious component can be integrated in our application because we didn't realize that it was hidden in the pull request or bad decision or something that we were not reviewed. Okay. At the end, what we want to avoid is that our customers are impacted by these malicious components or these vulnerabilities in our application. The problem or the question, the dilemma is if we have to select or the delivery, the speed of the delivery or the security. I'm here today to try to explain that we don't have to choose, that probably we can have both of them and to keep everything, okay? We are dealing with these changes because we are attending some changes in the threat landscape. First of all is the supply chain attacks, okay? They are being bigger and more sophisticated. For example, if we review some months ago, the first of them in September, we had malicious NPM packages that were infected by the Phantom Raven with, some interesting impact in the number of downloads. The problem or the intelligence of this attack was that the malware was not in the package. So the traditional tools could not detect this activity. In fact, they use some dynamic loading or external dependencies to escape these defenses in our systems, okay? So this is first approach of some intelligence in the new way of attacking. Then in September, it happens also something that was the say Hulot attack. In this case, the impact was huge. In the number of downloads and the number of packages was increased by a relevant amount of packages. The important thing is that here, the attack was based on still some credentials to change or take over the maintainers and introduce the malicious code in these packages using this steal of credentials. Okay, the thing is nobody realized about this after some time after the attack. We are going to see why this happened. The most relevant thing here is the massive scale that we covered here. Okay, and lastly, in November we had the version 2 of this attack. In this case, was a similar approach. The difference in this case was that it was not focused only on the NPM ecosystem, but also attack or infected part of the Maven ecosystem. So we have bigger impact in the number of packages and more intelligence and even a cross-language supply chain. So what we are seeing is that the attacks are smarter and bigger in the impact and are using some different things. What they are trying to achieve, they are not trying to crash the system or to impact the availability of our service. They are trying to access something that is more valuable for them. They are trying to access to our personal tokens, the keys for doing things, the tokens for automation, certificates, and things that can affect the privacy of our source code. So they are going to try to steal our source code or to access and compromise our infrastructure, and finally move across all the infrastructure of the organization. The result is that it's not only affecting one availability or one application. What we are exposing and we are compromising is the full pipeline, the full process of building and delivering the software and our infrastructure. Okay, so you can think, okay, we have an SCA, but the problem is that the SCA, the traditional software composition analysis, is not detecting these threats, because the way they work is they analyze the components you have in your application, you go to the database with the CVEs and this information, and then you do the match. So you only report the things that are known in this database. The problem is that these new attacks are using vulnerabilities that are not reported in any place. So they are unknown for this system. They are using these new vulnerabilities, malicious behavior. So at the end, you have to do threat intelligence and behavior analysis to put together with the context of your application and your organization to try to detect if the component is trying to do something that is not expected from the functionality point of view. Okay, so it's just to infer that something is not happening as expected. So these capabilities are not in the traditional software composition analysis and are the things that we need to put. The second point that we are facing is that developers are using new copilots, Copilot from GitHub, ChatGPT, Claude, and whatever. This is good because they are accelerating the development. The problem is that they are introducing new type of vulnerabilities. Okay, first of all is the dependencies. This is the data. 20% of the code are using invented capabilities or invented packages or invented dependencies. This hallucination exposes us to typo squatting or dependency confusion attacks because they can use these attempts to put the malicious component with those names, so the developer is not going to realize that this is a fake component and is going to introduce the malware in our application. And the second point is that half of the code that we generate with this assistance contains vulnerabilities, and are vulnerabilities that are different from the vulnerabilities we have today. For example, they are more related to logic flows or missing security controls or some insecure patterns. The problem is that our SaaS tools or the traditional SaaS tools are not detecting these new vulnerabilities because they are using patterns that have not been used by humans before. They are inventing new patterns, and the traditional tools works in a different way. For the tools, they are no known bad patterns, okay? The traditional tools are going to search for, or the traditional application security is going to ask, I'm avoiding an SQL injection in this point, depending on the flow and these kind of things, are prepared to find some patterns or some flows or some things that we usually detected based on the human programming style. The problem is that these new patterns are different, and probably is not the other thing is that if a developer review it, is not going to see the vulnerability. For example, if you ask an assistant, create a code for authenticating a user in a web application, is going to generate some code that for sure is going to work and is going to authenticate a user using the username and password. The problem is that it's not going to consider the expiration of the tokens or storing the information in a secure storage in some place. So it's like a lack of these things that we mentioned before regarding that is not complete. Okay, so these are new flaws that we have to consider, and we need to detect these new patterns and these new logic problems, because now the vector attack is the business logic, is not something that is not properly developed. Okay. The other point is, if this were not enough, we are dealing with new attacks in the supply chain, new vulnerabilities that are unknown and not detected by the traditional tools based on static analysis and these kind of things. And then we have the regulatory approach. CRA and Artificial Intelligence Act, okay? They are from December 2024. we have 3 years in theory, but the problem is that most of the organizations thinking that hey, they have 3 years have not started doing anything, and probably they are 1 year behind they should be. Okay. The problem is if they want or they wait until next year or until the last year to start doing things, they are going to have in a hurry, because this takes time to generate all this evidence that are going to us with this. The main problem of these regulations is that they demand continuous evidence. It's not they change the way we work until now. Now we generate an Excel file with the list of vulnerabilities, the result of managing them, and we have like on demand on specific times how we do this part. The problem is that this have to be continuous now. Continuous for evidence for what? For risk assessment, how we detect any vulnerability in the supply chain, in the complete life cycle, how we manage these problems, or how do we do the triage, the remediation, and everything. We have to ensure that we check things that are secure by design, like authentication, access control, encryption, login, and all these things. For sure, we have to do the incident reporting and these kind of things, but this is probably automated in a different way. It's not related with how we detect the risk and how we manage them, okay? The problem, as we mentioned before, is that our teams are dealing with these 3 new challenges, and they are using traditional approach. This doesn't match, because at the end, our teams are using probably one SaaS tool for one place, software composition analysis in other place, a secret tool to detect secrets in a different way. Every tool has a different user interface, probably is using different severity categories. As a result, the team people has to go tool by tool, extracting all the vulnerabilities, doing the correlation, trying to find duplicated things, and they are investing a lot of time to do all this activity. The problem is that this approach of doing manual triage is not scalable. So we need something to solve this part. With this, as we have a lot of tools, okay, we are generating a huge amount of different alerts, okay? Well, you have the numbers here, but probably we can count on 1,000 daily alerts. The problem is that you can manage probably 10% of these alerts, so the backlog is growing, and growing, and what we need is to manage this part. When you have a backlog that is you cannot manage, the result is that you are going to ignore the vulnerabilities. And in fact, 30% of the companies are ignoring more than 50% of the alerts. The main risk there is that probably you could lose some important vulnerability or important alert there, okay? How we can support this part? With the concept of ASPM. ASPM, the Application Security Posture Management, support these teams to put everything together. The idea is, let's put all the tools, all the findings in one place, okay? And let's use the context information to do the prioritization and the assessment and the remediation, everything together, based on actual impact in the security of the application. Once you have everything here, you can use contextual information from the technical and business point of view. If the application is deployed, if it's exposed to internet, if the vulnerability is reachable or not, if something is exploitable or not, based on your specific infrastructure, exposition, and usage of the different elements. Even, for example, for CRA, next year, the software developers cannot deliver software with public exploits. Okay, so it's something that you have to manage and you have to solve before delivering any release you have. You can use all this information to build your prioritization criteria and your prioritization funnel. The important thing is, instead of analyzing all the vulnerabilities, let's focus on what is actually affecting my security, what is exploitable and is important for my security and my application. Everything from a single point of view and putting focus on these things that are important for me. We are saving between 40–70% of the effort in the triage, and we are going to focus on remediation, not doing analysis or searching what is actually important for me. So you are saving a lot of hours and a lot of effort for these things. But ASPM is not only filtering the noise and prioritization, it's also providing continuous protection and protection against these two different new attacks or new vulnerabilities that we are facing. For example, for the supply chain, the idea is to provide some capabilities that detects this behavioral malicious or this malicious behavior in the components before doing or having any CV, before anyone has reported and validated it. So the idea is let's subscribe or let's analyze all the packages, all the versions of the packages, and we can do this behavioral analysis and put into context. So we can detect if it's filtering information, is doing something strange in the post install and these kind of things. So we can suspect that something is suspicious or is malicious before reporting or doing the specific analysis. From this moment, once we have detected that a package is malicious, we are going to raise an alert without waiting the publication in any database or anything. So from this moment, you are going to have an alert saying that you are trying to use or malicious packages is trying to be integrated in the pipeline, in the build. Sorry. The second part is you can automate that some guardrail or some security gate to stop the build, for example, in case of detecting this unknown malware. For example, to protect against this, say, Hulu and these kind of things, if we detect that the package is doing something malicious in the post-install, is filtering a secret or something that we can consider private, we can stop everything to avoid integrating this component in the pipeline. So we are providing something that is proactive. That is the way that this supply chain attacks is working now. We can detect these zero-day malware attacks in our processes. Okay. Then the second thing that we have to protect is against these new vulnerabilities that we are integrating or we are adding using the assistance of the AI. Okay. In this case, two things. We have to detect the new patterns that are integrating through this new code. Then we can use also artificial intelligence to solve this. The problem is that code that is generated with these assistants are probably generic, and we can use a specific trained assistants to do the security remediation, and we can double check if the solution is good enough before delivering and to put in that part. At the end, we are using also artificial intelligence to detect the intention of the code and to fix the vulnerabilities of these new patterns. But the developer or the responsible has the final decision. At the end, we are not changing anything automatically. So the developer has to review and accept the change to ensure that everything works as expected and we cover all the things. And something that is very important, we are doing everything automatically. At the same time, we are gathering information about the timestamp with the detection, the remediation, and everything, because we have the compliance later. Okay, so we have to store all these things. One important thing from a productivity point of view is to put all these capabilities in the environment of the developer, because the idea is to avoid that the developer puts something, goes through several pipelines, have some delay, reject the change, and then back here to remediate the problems that you are having things. So in the developer environment, we can put all this detection, remediation, and even preventive mechanisms to ensure, for example, is going this release past all the guardrails, all the security gates that the DevOps team has in the pipeline, just to avoid reworking and all these things. We can also check remediation, if it's valid for the application or if it's going to break something. So developer can advance work to avoid the reworking and to accelerate the process of delivering code from the moment of the development. If everything is integrated with the assistants, so when the assistant generate code, can automatically invoke the capabilities of the platform. So they can even resolve or flag the vulnerabilities before delivering to the IDE. So the idea is that the developer is going to release secure code from the start, okay, without doing anything or remediation later. And finally, we have the compliance. We mentioned we need real-time evidence gathering. We cannot do export several files or exporting the list of vulnerabilities and everything. So based on the regulations that we are focusing, we need to monitor several things. We have to ensure that we have evidence of all the scans that we have done, okay, the result of every scan, different things, the number of vulnerabilities that we are generating, that we are solving, and the different KPIs like exposure window, time to remediate, time to discover, and all these things, and even validating if it's inside the SLA that we have put in the organization. Okay, we have to have the time to remediate below 30 days, for example, to ensure that everything is in this part. So the idea is to have this information in real time continually with all the activities that we have in the platform. At the end, we implement this through these 4 pillars, let's say. One is the productivity. The idea is to make the security teams take the maximum benefit of removing the manual activities to focus on what is important. Okay, let's remove the noise and let's remove the manual activity in the triage and these kind of things. Automation in every place, in the detection, in the remediation, in the evidence generation, in all the places. So the idea is that everything works automatically without manual interaction. We use the artificial intelligence for remediation to save around 50% of the time required for this, okay, and for anomaly detection that we have mentioned, not only from the software point of view, but also even the activity. For example, if someone steals the credentials of a user and suddenly you start seeing anomalous activity in the SCM from a different country or strange hour, okay, you can detect all this anomalous activity of the people also, so you can act immediately through your SOC to avoid any attempt of attack exploiting the vulnerabilities that we have detected. And finally, put everything in the development team, just to try to remove all the effort to the following teams. As a result, as I started saying this part, I think we don't have to choose between speed or security. We can have both of the best of both worlds because we can do all this secure development from the start. We can deliver as much secure code as possible from the beginning, keeping the pace of the development team and supporting them to do everything secure from the beginning. The teams, from the security point of view, with automation, can check everything and can check all the changes, even can stop any attempt of this new type of attacks immediately. And we can block these malicious attacks in this part, and we can gather everything in real time to be prepared for the audits in Network. So this is all. Thank you very much.